Usually, the last thing on fruit and vegetable growers' minds when it comes to their processing equipment is food safety. The FSMA Produce Safety Rule states that you must use equipment and tools that are of adequate design, construction, and workmanship to enable them to be adequately cleaned and properly maintained. Growers should understand how the design of their equipment can affect the safety of their produce in order to avoid an outbreak in the future. Hygienic or sanitary design, as defined in the Produce Safety Alliance Grower Training, is the art and science of developing materials and building equipment that can be easily cleaned and sanitized. Bacteria are very, very small, and there are many places for them to hide. They thrive in tiny areas on equipment that are not easily accessible, such as cracks, gaps, or porous material. When equipment is constructed with proper hygienic design in mind, its ability to harbor pathogens is reduced, which leads to safer fruits and vegetables. Chris Callahan of University of Vermont has explained 5 key principles of hygienic design to consider when evaluating equipment. These include visible and reachable surfaces, smooth and cleanable surfaces, no collection points, compatible materials, and preventing contamination. Throughout this video, we'll dive into each one of these principles and provide examples of what to look out for. Equipment needs to have visible and reachable surfaces in order to be effectively cleaned and sanitized. Callahan explains, if you can't see it and you can't reach it, you can't clean it. Surfaces do not need to be fully accessible at all times, but it's ideal that the equipment can be easily taken apart for cleaning and other maintenance. Along with being accessible, surfaces on equipment should be smooth and cleanable. Surfaces made of plastic, for instance, are smooth and water-resistant, making them easy to clean. On the other hand, a porous surface such as carpet is more difficult to clean, sanitize, and fully dry. Continuous welds that are rounded or sanded down are best because they are smooth and easy to clean. Intermittent welds, sandwich joints, or lapped layers of material create gaps and are not easily cleaned. The third key principle of hygienic design is avoiding collection points. As stated before, gaps, cracks, or hollow spaces, such as the inside of tubes that are not completely sealed, can be impossible to clean. Because of this, these areas collect dirt, debris, and moisture, creating favorable conditions for bacterial growth. Collection points can also lead to early corrosion of materials. Equipment materials should be compatible with both the produce and cleaning and sanitation methods used. It's also important to consider how the materials will react with the chemicals in cleaners and sanitizers. Incompatible materials could rust, crack, flake, or show other signs of wear, which then could become a physical or chemical contamination risk. Lastly, the construction, placement, and area surrounding the equipment should work to prevent any sort of cross-contamination. For example, floors should be swept, trash should be emptied, and any staining water should be eliminated. This also includes excluding pests or other animals from the building. This may be done with rodent traps, rafter netting for birds, or other various animal exclusion methods. Equipment does not need to be perfect. Even with brand new equipment, there are always improvements that can be made when it comes to hygienic design. However, making incremental improvements with these 5 key principles in mind is a huge step towards safer produce. Most of the equipment featured in this video can be found at the Purdue Extension Food Safety Training Hub.
The Purdue Extension Food Safety Training Hub was established in 2019, and it was through a partnership with the Food and Drug Administration as well as the Indiana State Department of Health. These funds went to develop the hub that we use for hands-on training for growers so they can better understand good agricultural practices that they learn in the courses we teach. We have the ability for post-harvest processing and to have equipment where we can show these practices real-time to growers.